Are we getting somewhere? Or is there a question you feel like asking?
The only thing I don't really understand is how you interpret the numbers like 40 or 12. Like, what do you do with that?
Yes. So that is a very good point. How do you actually interpret the numbers that we got? Because they are still floating out there somewhere in mathematical space, and we can't really ground them in reality. I feel, yeah. Well, what we do with them in the end is the following. We can now say, oh, if you look at the three outcomes you got, then it turns out that the total variation can be perfectly split up into two parts that don't overlap each other. It turns out that the total variation of 52 is the same as the explained and the unexplained variation added together. So what you can then say is that part of the total variation was attributable to the independent variable. So we could say, well, part of the variation in the accidents can be explained with the plates variable, and part, actually the largest part of the variation, must have something to do with residual factors. This then lets you do the following. It lets you ask how much of the variation, expressed in a percentage, can then be explained by the independent variable. The proportion of explained variation is also how we refer to this thing. And what you can say is the 12, the explained variation, compared to the total of 52, well, it's a fair portion. It's 0.23, or in other words, it's 23%. And now this number, I feel, is reasonably tangible. So now we can say 23% of the variation in the accidents is related to the fact that some waiters were carrying more plates simultaneously than other waiters were doing. This also means that the remaining 77% of the variation in the accidents must have been, well, dare I say, caused by other factors. I should not say caused, as you will remember from the fact that correlation is not causation. But in principle, 77% of the variation in the accidents is related to other factors than the plates variable. This is a bit cruelly. I wonder if you could say, well, the plates variable is 23% responsible for the variation in the accidents. That is only if there is truly a causal link, huh? But maybe that feels a bit more intuitive. Point of interest. We have a symbol for this thing. The proportion of explained variation is often written down using a particular letter. Do you know which letter it would be? It would be R squared. R squared is the common symbol for the proportion of explained variation. R squared. R squared. Yeah, as it turns out, you can actually just square the correlation coefficient, and this is also going to give you R squared. It turns out that those two things are completely related to one another, that one measure of how strongly two variables are related, it can perfectly be transformed into the other. In a way, we are still expressing with R squared how strongly the plates variable is associated with the accidents variable. And so, yeah, one mathematical expression of this relationship, quite surprisingly, and then maybe again not so much, these two measures turn out to convert really well from one to the other. It could give you the impression that we have just wasted a lot of our time. But on the other hand, that's not really true, of course. If we want to understand what R square says, then you have to talk about these sums of squares first of all. And if you're thinking, well, this looks like a way shorter calculation, that depends. If you already have the correlation coefficient, then sure. But remember what kind of a mess it was to calculate the correlation in the first place. So either method would take some time if you wanted to do a manual calculation. Mara.
Hi. Is there also a guideline for R squared, like how strong the association is?
Oh yes, I think you can just square the guidelines for the correlation coefficient. So if we said earlier that a correlation of 0.10 is small, then an R squared of 0.01 would be small. Okay. That's 0.10 squared. And likewise, correlation of 0.3 is a medium correlation. So that's, if you square that, you get 0.09 for R squared. And you can you can square 0.5 for the correlation. That gives you 0.25. And that is a strong proportion of explained variation. That was a really nice question, I must say. And with that, we reach the end of this video series. Thanks for watching. If you enjoyed it, check out our books. Link is in the description. And if you study in Maastricht, the Netherlands, consider joining one of our tutorials in statistics. I look forward to seeing you there. Bye!